Let's look at the solutions of geometrical bytes. If 6 solid cubes with edge 4 cm each can be placed inside a hollow cuboid whose two sides are more than 4 cm, such that no space is left inside the cuboid, what is the length of the longest rod that can be placed inside the cuboid? So I'm saying, let's say we have a top view. The only way you can fix 6 boxes inside it would be this way. You will have 6 cuboids placed here. So this length will turn out to be 12. This length will turn out to be 8. And the height, which is not visible because these are two-dimensional face, will be 4. So for the large cuboid, the dimensions are 8, 12, and 4. So the largest rod or the body diagonal will be given by under root 8 square plus 12 square plus 4 square, which translates to 64 plus 144 plus 16, which is as good as 224, which is as good as 4 root 17. Sorry, 4 roots, not 4 root 17, 4 root 14. This is 16 into 14. Under root 16 into 14, which will be equal to 4 root 14, or option A. Next question. The area of a rectangle is twice that of a square. The length of the rectangle is 28 centimeter and breadth of the rectangle is 4 by 7 times that of the side of the square. The breadth of the rectangle is. Okay, rectangle is something like this. This is 28. This is 4A. And the square is something like this. This is 7A. Area of the rectangle is given by 112A. And this is 2 times area of the square, which is 49A square. So cancel, 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 cancel. 56. A is equal to 8 by 7. And therefore, breadth of the rectangle is 32 by 7, or option A. Next question, perhaps the funnest question. A convex polygon is defined as a polygon that does not have any internal angle greater than or equal to 180 degrees. If the quadrilateral formed by vertices at 3, 4, 3A, 4, 5, 6, and 5, 6B is convex, which of the following statements are true? Okay, let us try and draw a diagram for this first. The 2 points that we are sure of, 3, 4 and 5, 6. So 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, and 6. So 3, 4, 1 point is here, and the next is 5, 6. 1 point is here. These are 2 points that are already identified. Now for these 2 points, where we don't really know the precise value, I'm going to change the color to something different. Can I say this point here, 3A, 4, will necessarily lie on this line, will necessarily lie somewhere on this line, and this point 5, 6B will necessarily lie somewhere on this point, somewhere on this line. Okay. Now going back to the original color, this is 1 point, this is 1 point, and the other 2 points are on these lines, blue lines. We need to ensure that this is convex. This is convex. Okay. If B is greater than 1, if B is greater than 1, it means the second point is somewhere at the top. This third point, this fourth point, 5, 6B is somewhere on the top, somewhere here. If this is somewhere here, can you see, if I take the fourth point, 3A, 4, to be somewhere here, it will not be a, let me draw it like this. If I took some point here, it will not be a convex polygon because this angle here will be greater than 180 degree. So we can't have that. Similarly, I cannot take it on the line itself. X equal to 5, I cannot have it on the line itself because then it will no longer be a quadrilateral. 3 points will be collinear. The only way it becomes a convex quadrilateral is if the fourth point 3a comma 4 is taken somewhere to the left of this line, or in other words, it turns out to be 3a is less than 5, the x coordinate is less than 5, or a is less than 5 by 3, and this is what statement 1 says. So this is absolutely true. This is absolutely true. Statement 1 is true. Okay, let me erase the unnecessary bits. You don't know where this fourth point is because only when a was greater than something was mentioned. Okay. Now coming to the second statement. If a is greater than 5 by 3, if a is greater than 5 by 3, then effectively we are saying this point is greater than 5, comma 4. So the next point has to be somewhere to the right. Let's say this point was here. Let's say this point was here. Then the fourth point that we are seeking, if it is at the top, it will turn out to be a non-convex polygon. If it is somewhere here, it will still turn out to be a non-convex polygon. Let's say the fourth point was here. Can you see it will turn into an arrowhead of sorts? It will not be a convex polygon. This angle here will be greater than 180 degree. So this is also unacceptable. The only way it remains a convex polygon is if the fourth point, or 6b that we have, turns out to be lower than this point, lower than this intersection point. If it is somewhere here, then it will remain a convex polygon. So basically, for the second case, 6b has to be lower than 4. This is 4, this is 5. Left of this, so we got this. It has to be lower than 4, so we got this. So b has to be less than 2 by 3. This is also valid. So statement 2 is also valid. Both these statements together are valid. As in both these statements are valid. So the answer has to be option D. The fun thing about this question is it is not based on the general geometric principles that we are familiar with. It is more to do with visualization, which a lot of people are not very comfortable with. So wonderful question. Next. In triangle PQR, the incircle touches the sides QR, RP, and PQ at T, U, and S respectively. So let me make a triangle. There is an incircle here. Okay. If the radius of the incircle is 4 units. 4 units. This is 4, this is 4, this is 4. Oh, we were also told this, no? PQR, I will have to name first. PQR. So QR at T, this is T, RP at U, this is U, and S is here then. Okay. The radius in circle is 4 units, and the length of QT, RU, and PS are consecutive integers. These three are consecutive integers. Let me go ahead and put this down as M. This is M plus 1. This is M minus 1. Cool. Then the area of the triangle PQR in square units. Okay. There is a mathematical way of doing this. There is a smart way of doing this. The mathematical way of doing this I will do first. The mathematical way of doing this would be in radius into semi-perimeter. In radius into semi-perimeter is the area, and we know if this is n minus 1, this will be n minus 1, this will be m plus 1, this will be m. So first semi-perimeter here will be m minus 1 plus m plus m plus 1, so 3m. Semi-perimeter is 3m. 3m into 4 is equal to under root of 3m into 3m minus 2m. So m 3m minus 2m minus 1, so m plus 1, and finally 3m minus 2m minus 1, so m minus 1. This is what we have got. So 4 is equal to, let me take it to this side, I will get under root of m into m minus 1 into m plus 1 whole thing by 3 is equal to 4. Okay. So 48 is equal to m into m square minus 1. Oh, 3 had gone here. 3m had gone here. Oh. So 3m. So 48m is equal to this much. M and m cancelled. So now we get 48 is equal to 7 square minus 1. M is equal to 7. Which should mean this is 6, this is 7, this is 7, this is 8, this is 8, and this is 6. So now the length of the sides will turn out to be how much? Oh, sorry, length of the sides is 13, 14, 15. Area of the triangle, we can happily turn it into 3 into 4 into 7, which is equal to 84. This is one technical way of reaching the answer. The other way, if you are aware of, there is a, see, as soon as they've told me that the side lengths, or at least the portions therein, m minus 1, m plus 1, they are consecutive integers. Hopefully you are reminded of a triangle by the name of Heron's triangles. You've got triangles that are of three consecutive integer lengths, and yet the options are all integral. The most commonly used Heron's triangle is 13, 14, 15. If you can simply confirm, if the end radius in this case turns out to be 4, you can happily calculate area from here. That is another way. The last way in which you can potentially do it is, what is the area of this circle? Can you see the area of the circle will be 16 pi? Area of the circle will be 16 pi, which is greater than 48. And among the available options, there is just one option that is greater than 48. In any case, you will reach the answer 84 every time. Okay, last question. The perimeter of a square is 24 centimeter more than twice its diameter. So 4a minus 24 is equal to 2 into 2 root a. Sorry, 2 into root 2a. This much we know. So a times 4 minus 2 root 2 is equal to 24. Or a is equal to 24 by 4 minus 2 root 2. This much we know. Now we were asked for area of the square. We've already got side. So area would be given by a square is equal to 576 upon 16 plus 8 minus 16 root 2. Have I done it correctly? I could have removed 8s easily. I can remove 8s easily. So if I remove the 8, I get 72 by 3 minus root 2. but none of the options match what I have. I have option C, which is very similar to it, but it doesn't really match it exactly. So next thing to do is rationalize it. You multiply it by 3 plus root 2 and 3 plus root 2. So 9 minus. Have I done it? Okay, it should be 2 root 2. It should be 2 root 2. Yes. So 9 minus 8 in the denominator is as good as 1. What you're left with is 72 into 3 plus 2 root 2. So yes, option C will be the correct answer. That will be all for this episode. Hopefully you learned something. Okay, bye.